All right, let's jump right in. Welcome to this explainer. Today, we're taking those incredibly dense, honestly overwhelming SQL cheat sheets and turning them into a clear, empowering progression. We're going on a journey today from the absolute basics all the way up to the advanced, pro-level patterns you actually need for modern data work in 2026.
You know that feeling when you're just staring at an ocean of SQL syntax? It is super easy to get completely lost. But by the end of this explainer, you're going to have a structured, intuitive understanding of this entire ecosystem. We're going to master everything from foundational commands to optimizing queries that handle literally billions of rows. It's all about building out that skill tree, just one concept at a time.
So here is our roadmap. 1. Core SQL building blocks. 2. Mastering data relationships. 3. Aggregations and advanced queries. 4. Next-level window functions. 5. Handling modern JSON data. And wrapping up with 6. Pro tips for 2026.
Let's start right at the beginning with Section 1, Core SQL Building Blocks, the foundation.
Okay, the very first thing you've got to do is mentally separate how you manipulate your data from how you actually define your database structure. On the DML side, data manipulation language, you have your core daily drivers, right? Select, insert, update, and delete. But over on the DDL side, data definition language, you're managing the architecture itself. That's using create, alter, drop, and truncate to build, modify, or totally wipe your tables. You really want to keep these two buckets separate in your head.
Let's be real, user data is pretty much never perfectly clean. So string functions are basically your first line of defense. Things like concat, substring, and trim are absolutely essential for fixing messy inputs. And for managing timelines, date functions are totally non-negotiable. Using current_date or dateAdd lets you instantly perform this sort of time travel math, like finding out exactly what your metrics look like 30 days ago.
All right, moving right along to Section 2, Mastering Data Relationships, Connecting the Dots.
Think of an inner join as a really strict bouncer. It's a strict intersection that only returns rows having matching values in both of your tables. But a left join, it's a lot more forgiving. It grabs everything from your left table, and if there happens to be a match on the right, it pulls it in. If not, it just fills those empty gaps with nulls. It's basically the difference between saying, only show me customers who actually bought something, versus show me everyone, and just list their purchases if they have any.
Now, listen up. You've got to be incredibly careful with a cross-join, which creates what's called a Cartesian product. It combines every single row from the first table with every single row from the second table. So if you have 1,000 customers and 1,000 products, boom, you just accidentally generated 1,000,000 rows. It's honestly a fantastic way to accidentally nuke your production server, so definitely use that one intentionally.
Next up is Section 3, Aggregations and Advanced Queries, Finding the Bottom Line.
Okay, this is one of the biggest gotchas in all of SQL, filter timing. Both of these commands filter data, obviously, but the where clause filters individual rows before any grouping happens. The having clause, that filters the groups after they've been aggregated. So if you want categories with more than 5 products, you group them, you count them, and then you use having. Seriously, never mix these up.
Now, as your queries start getting ridiculously complex, your code really needs to stay clean. Enter Common Table Expressions, or CTEs. By using the with clause, you can break massive, heavily nested subqueries into readable, modular little chunks. You build your logic step by step, almost like you're defining variables at the top of a script. It makes debugging infinitely easier down the line.
Which brings us to Section 4, Next-Level Window Functions, the Magic Abilities.
The absolute magic of window functions is that they solve a massive, massive headache. See, standard aggregations with a group by collapse your rows, meaning you completely lose all that individual row detail. Window functions, however, let you perform calculations across a set of related rows without collapsing a single thing. You get to keep your original rows, but you gain this entirely new column with deep analytical math running right alongside them.
Let's do a rapid-fire breakdown of these ranking functions. Row number gives you a unique, guaranteed sequence. Rank gives the same number to ties, but it leaves gaps. Dense rank ties 2, but leaves no gaps, so it goes 1, 2, 2, 3. And n-tile, that buckets rows into n groups. Say you need to instantly find the top 25% of your customers, n-tile 4 perfectly spits them into quartiles. Such a massive time saver.
Oh, And pay super close attention to this trap. Actually, it's more like a classic rookie mistake. When using last value, the default frame for an ordered window actually ends at the current row. It doesn't look at the whole partition automatically. If you don't explicitly pin that frame down by typing unbounded following, it just returns the current row's value, which will absolutely break your logic.
All right, on to Section 5, Handling Modern JSON Data, the 2026 Reality.
Whether we're talking event payloads or third-party APIs, querying JSON right inside the database is just a fact of life now. Now, while the extraction syntax diverges a bit depending on your dialect, PostgreSQL uses arrows, MySQL uses JSON_extract, and SQL Server uses JSON_value, the overall architecture is exactly the same. You are pulling specific nested fields directly into your select statement, which completely saves you from having to export these heavy payloads out to your application code.
And finally, we've reached Section 6, Pro Tips for 2026, the boss level. If you want those lightning-fast queries, these are basically your non-negotiables. First up, filter early to eliminate rows immediately. Second, literally never use select star in production. Only ask for what you actually need. Third, for those large subqueries, use exists instead of in, because exists stops looking the second it finds the first match. Always index your join and where columns. And critically, never wrap indexed columns in functions inside your where clause. It completely bypasses the index.
Okay, let's talk modern patterns. Upserts, where you insert if it's new or update if it exists using onConflict or merge. Then there's table sample. This one is huge. If you need to eyeball a billion-row table, an order by random will literally crush your system. Table sample just grabs a fast percentage right at the storage layer instantly. And lateral joins? They let you write per-row subqueries that reference the outer query. It's the ultimate cheat code for those tricky top-end per-group problems.
So, when you take a step back, the whole chaos of SQL syntax actually organizes itself pretty beautifully. By grouping the basics, the filters, the joins, and those complex aggregations into distinct mental models, you really lock in the architecture we've just journeyed through today.
We've covered a ton today. The core building blocks, the sheer analytical power of window functions, modern JSON extraction, and high-performance optimization patterns. The entire skill tree is basically mapped out for you now. So the question I want to leave you with is this. You know the architecture. How are you going to apply these 2026 patterns to optimize your next billion-row query? Thanks so much for joining me on this explainer, and hey, happy querying.